Backplot is basically a quick way to check the movement of tools to ensure that they are behaving the way we want them to, whereas Verify is a much more in-depth tool that can simulate multiple toolpaths at a time and can actually give you some very valuable insights into the way that a tool is cutting, or at least how it will cut. So for Backplot, all we need to do is select a toolpath, as we have here. You can see the toolpath lines are all showing. And then we're going to go to the Backplot Selected Operations button, this one right here. Upon clicking on that, you'll notice a representation of our tool gets brought up on screen, and we have a few different little options here. First of note is that we can click play here and adjust the play speed to watch this tool actually cut material. Now, in this particular view, the backplot view, this is not going to show actual material being removed. It will give us a good idea though of how this tool itself will move and how it will enter material or enter the part. You'll see it's doing this nice spiral cut down around this island. It's then cutting some other quick features here. And it's working its way into this island. So it is cutting these features in steady lines to try to keep consistent cuts. Looking pretty good. It's cutting around all the different objects. Good. You can see these orange lines are used to represent areas that have been cut. It's finishing our different shapes now, spiraling down around our last feature, and creating our final cut there. So you can see the orange areas represent what's been modified, and you can see we had a pretty consistent cut all the way across the entire surface of this part. Now this is the nicest thing about this type of toolpath obviously is that it can cover a lot of area, as the name suggests, in fact, area mill. But being able to actually verify our toolpaths after the fact, see how they cut, see if we need to make changes, is very valuable. And if you did watch the last tutorial, this would also be a good way of seeing, for example, when I noticed that the tool lines were going to rapid through a feature of the part, you would also have been able to see that by using this backplot. You would have seen the cutter drive itself right through one of these islands, and we would have noticed there was a problem. So just a nice little feature to quickly observe how a particular tool will cut the given geometry. In this tutorial, we're going to look at the Verify simulator within Mastercam. In order to access the Verify simulator, we can come up to the top of the Toolpaths tab of the side panel. And right here you'll see an option that says Verify Selected Operations. Now the latter half of that statement is very important. It will only work on selected operations. So you can see this operation is selected. It has the check mark on the folder. And we can also tell it's selected because we can see the toolpath lines here. So we're going to go up here to the Verify Selected Operations. And when you click this, it will open up another window of Mastercam. Now for me, I'm going to full screen this. And from this window, you'll notice that we can actually see our stock model of the material before any of the features have been cut. Depending on the speed and age of your computer, you may want to adjust these settings at the bottom before beginning the playback. You may want to slow down the simulation speed a bunch because it goes very fast by default. And you may want to turn this slider on the left to performance if you have a slower computer, or precision if you'd like a more accurate representation of the cuts, but it will be harder on your computer. So I will leave mine in the middle for this one, and I will slow down the cutting speed. A couple other quick notes. I can toggle the visibility of different features, elements here on the workspace. I can, by clicking on the check mark for tool, I can change it to either a check mark, a blank square, or a filled square. A filled square will make something transparent. So you can see now I can still see the tool, but I can also see behind it in case it's obscuring some part of the object it's cutting. Over here I can adjust the stop conditions. So I can enable them by selecting here. And I can select which stop conditions I want by clicking the drop down. So for example, collisions. mainly would be what I'd be worried about. So I've enabled collision checking and turned on that as a stop condition. So if at any time the tool hits the part, not by cutting it, but it collides, then the program will stop and I'll get a warning letting me know that there's a collision. In the verify section up here, this tab at the top, I can enable color loop, which normally, if there was multiple toolpaths in this program, it would make each toolpath's cut marks a different color to identify which toolpath is causing a problem if there is any issues. Here it doesn't really matter because there's only one toolpath, so I don't have to enable that. Okay, so let's watch through this, and then I'll show off one final tool that Verify can use, which is the compare option, but we'll do that last. So first, let's watch this through. So I can click play, and you'll see the cutter comes down, starts spiraling into the material as it is, and we can speed it up or slow it down to watch things at different paces. So I'm going to speed it up a little bit. We can watch these cuts being made, all the material being machined away, and then there we are. We're done. So the next step we could do is open up the Compare tab here. Now the Compare tab allows you to set up your tolerances for a part, and then it will change the color of each feature, showing whether or not it was cut to size and within tolerance. To adjust your tolerances, you can tweak them manually, or you can come up to this button here, Compare Options, and you can adjust your tolerance here. So if I type in 0.001, a 1 thou tolerance on all cuts, I can say OK, and then you'll notice over here, green is the sought after nominal size, which is plus or minus 1 thou, and then the lighter, the more blue it becomes, the more it is oversized, and the more red it becomes, the more it is undersized. So let's see how that affects our model. So we can click this refresh button here, and you'll notice that our model now gets color-coded to reflect these changes. So you'll notice dark blue represents that a feature has at least 2 thou excess material sitting on it, but not as much as 4 thou in this case. Unless actually this is the darkest blue, which is also possible. That might be what's actually happening here. If I adjust my tolerance to be a little more lenient, perhaps I'll make it 10 thou instead of 1 thou. Refresh again. Then we can see a couple more little factors coming into play here. Now, something to take note with Mastercam, it has a few different simulator options that will affect the accuracy, especially of the compare tool. If I put this back to 1 thou, say OK, refresh, you'll notice that, for example, it's saying there's stock being left on this island, even though we told our cutter to cut this to the finished size. What's happening here is that Mastercam has two different simulators. It has the 3-axis or 5-axis simulator. And for some reason, the 3-axis simulator doesn't simulate cutting walls very well. So what we can do is come up here to the File tab, and we're going to go to the Options, and then scroll to the bottom and select 5-axis. And I can say OK. Now keep in mind that this does not mean that you have to run this on a 5-axis machine by any means. All this is saying is it will use the 5-axis engine to simulate the part, which in this case, if we're having trouble with it, it should run a little better. So I'm actually going to refresh the compare feature before we even start cutting here, and then I'm going to hit play. What this will allow us to do is actually see features come into the green color as they're cut, which is kind of a nice feature. Okay, so now we can see the walls are all green, but there is some material remaining on top of some of these faces, which is just because we didn't program in a tool to cut those features. But all of the parts that were cut are very close or perfectly within tolerance, so that's really nice to see. So that pretty much wraps up this tutorial. I think that's a good place to leave it, and that covers simulation within Mastercam.